All right, note 7, overview and intro to trig equations. All right, guys, focus, focus. So a lot of the ideas are already ideas that you guys should already be familiar with. Now, according to the exam that you guys took, some of you are pretty good, and some of you, I don't know, like, some of you, like, didn't know much of anything. And I haven't been seeing you come in to tutoring. So, guys, like, ask questions and come in if you don't know what's going on. All right. And I'll pass back your grades in a little bit. I already graded this class. This class is already, your grades in the grade book. No, I didn't. Sorry, miss. But I do have yours on file, though. Question number 1. Express as a function of a different angle. So how do you tackle this question? It says sine 47 degrees. All right, focus, guys, focus. So the way we tackle this question is that 47 degrees is in quadrant 1. So what you should be thinking about is sine is a y value in quadrant 1. And in quadrant 1, sine is positive. Well, everything's positive in quadrant 1. Where else is the y value positive? In quadrant 2. So this 47 degrees, you can say that's like a reference angle. And then you can just go, well, if I'm in quadrant 2, how do I figure it out? You just go 180 minus 47. Let's see, what's the difference? 47, 57, 67, 77, 33. So that's 133 degrees. So this must be the same as 133 degrees. Do you guys see how we did it? Do you see the logic on how we did it? Okay, so now check this out. If you have a calculator and I type sine of 47 degrees and I push enter, I get this number, this ratio. If I type in sine of 133, it better be the same according to this. So sine of 133, I push enter, and look at that. It's the same digit per digit everywhere. Does that make sense, guys? Like it should be, it better be, because sine's that y value, and look, we got it. All right, let's go to the tan of 150. 150 degrees, here's how you should be thinking. 150 degrees is in what quadrant? 2. So tan, remember that tan is y divided by x. In quadrant 2, is y divided by x positive or negative? Negative. So where else will my ratio y divided by x be negative? Quadrant 4. So the way to think about it is this. What is my reference angle when I'm at 150 degrees? Uh-oh, okay. Yeah, 180 minus 150. So that's 30 degrees, right? So that means you're 30 degrees away from a full revolution if you're in quadrant 4. And then just grab that calculator by your non-dis over there. Later, miss. So 30 degrees away from a whole revolution. So that means I'm going to be at 330, right? Yes, ma'am.
What did you compare it to a whole revolution?
Because you guys told me that y divided by x is negative in quadrant 1 and in quadrant 4. And I told you that the 30 degrees is a reference. So you're 30 degrees away from a full revolution if I'm in quadrant 4. Does that make sense? You didn't have to do that. You could have always, 150 is a perfect coordinate. What do we say? This was 330? 150 is a perfect coordinate. You could have just been like, well, Chavez, I know y divided by x, so y is a half. X is a negative square root of 3 over 2. And look, negative 1 over square root of 3. You could have just said, where else are you negative 1 over square root of 3? What, 330 degrees, guys? The y value is a positive half. I'm sorry, negative half. And the x is a positive square root of 3 over 2. And notice the 2's cancel out, and you just get negative 1 over square root of 3, which is the same answer. Does that make sense? Okay, so we just did it 2 different ways. Or 3 if you count the other one. Okay. Cool or not cool? All right, so look, check it out. If I take my calculator and I go tan of 150, I get this number. That number is negative 1 divided by square root of 3. Look, negative 1 divided by square root of 3. I didn't even put the division sign. Negative 1, I'm all messed up today. Negative 1 divided by square root of 3. Look, guys, negative 0.577. So tan of 330. And look, negative 0.577. Cool or not cool? Am I making sense? Okay. Let's go to the next one. So notice this one you already know. So sine is negative square root of 3 over 2. On the unit circle, there is a perfect coordinate. At what degree is sine negative square root of 3 over 2? Now, 120 is positive. Remember that y is, that sine is a y value? So I'm in quadrant 3 and quadrant 4. So not 120, but 240. That's one of them. And then I have another, the one in quadrant 4. 300. Yeah. Does that make sense? Okay. Here we go. Okay. No problem. Okay, so if you want another way, maybe you're thinking, Chav, like I haven't memorized the unit circle yet. Is there another way? Yes, there is. There's always another way. Remember that if you want to get the reference angle, I write theta r. And if you want to get the reference angle, you just drop the negative. Arc sine of square root of 3 over 2. If you type this in the calculator will spit out 60 degrees. That's my reference angle. Yes or no? So yeah, check it out. Take out my calculator and I go arc sine and I go square root of 3 over 2. Notice that I'm putting it as a positive, not a negative, because it is a reference. So 60 degrees. And then here's what you ask yourself. In what two quadrants is sine negative? Quadrant 3 and quadrant 4. Yes or no, guys? All right. In quadrant 3, if this is my reference angle, how do I find my theta? No, not subtract. Add 180. Do you guys know what I'm talking about? All right, let's do a visual. Let's do a visual, guys. You have a unit circle. All right, I'm going slow. Don't write any of this down. Just listen so we can observe. I told you where's arc sine 60 degrees? Arc sine square root of 3 over 2. Where is sine square root of 3 over 2? And you told me 60 degrees. And then I told you where is sine negative? And you told me quadrant 3 and quadrant 4. So this is my reference angle. So that means I'm going to go 60 degrees like this and 60 degrees like this. So if I'm in quadrant 3, this angle here has to be 180 plus 60. See? And this angle here in sky blue, well, this is only 60 degrees away from the revolution, from one revolution. So 360 minus 60. So what are my angles? 240, because I got that from 180 plus 60. And what is the other one? 300, because I got that from 360 minus 60. Does that make sense? And there's so many ways to do it. It's not even funny. If you have a calculator, you can use the calculator. If you don't have a calculator like the unit circle quizzes, then you're going to have to know it. Cool or not cool? All right. Tan. Where's tan negative square root of 3? Relax. If you remember your unit circle, that's wherever. Okay, so where does this happen? I need square root of 3 over 2 to be in the top, and I need the bottom to be a negative half, because that will reduce to a negative square root of 3. Or I need the numerator to be a negative square root of 3 over 2, and the denominator to be a positive half. Remember that tan is y divided by x? So I need, what do I need? I need the x coordinate to be a negative half, and the y coordinate to be a square root of 3 over 2. Or I need the x coordinate to be a positive half, and the y coordinate to be a negative square root of 3 over 2. Do you know where those two coordinates happen? It's in quadrant 2 and in quadrant 4. So this one here in quadrant 2 is theta equals, where is my x value negative half and the y value square root of 3 over 2? Yeah, no, not 150. Sorry, it's 30 degrees away from the 90 degrees. 120. And there's another one in quadrant 4. $300. Right? Okay. If you don't know how to do that, relax. You have a calculator. You can find the reference angle like this, guys. You can go theta r equals arc tan of square root of 3. Notice that I'm putting square root of 3 and you will get 60 degrees. Look, arctan, second arctan, and what did I say? I already forgot. Square root of 3. Arctan of square root of 3. I push enter, and look, you get 60 degrees again, guys. So that's your reference angle. We know that tangent is negative in quadrant 2 and quadrant 4. So 180 minus 60 is 120. 360 minus 60 is 300. Yay or nay, guys? Okay. So look at question 5. And relax, we're going to go really slow. Really slow. Okay, here we go. Draw a horizontal, vertical, or diagonal line to represent the equation sine theta equals negative 0.2, and then use the line to help you solve the equation between 0 and 360. So sine, is it the y value or the x value? The y. So this is your unit circle. Go to negative 0.2, and then follow the circle and put a point. Follow the circle, put a point. Do you see how I put my point at negative 0.2 for the y value? All right, connect it to the origin. So, like this. There's one, and I'm going to do the other one in a different color. Oh, man. And there's another. All right, these are the angles they want, guys. You guys ready for the angles? I'm going to go slow. This is the angle they want. They want that angle. And they want, oh, let me change the color on that. And they want this angle. How do I figure this out? Here's how you figure it out, guys. I'm going to go really slow. Use the reference angle to help you out. So I'm going to find my reference. I'm going to erase all this here. So look, I'm going to write theta r. That's your reference. Equals arc sine, and then turn it into a positive. 0.2. Chav, why are you turning it into a positive? The reference angle is never negative. And the calculator is stupid. If you type arc sine of negative 0.2, it's only going to give you one answer. And we know there's two of them. Are we okay so far? All right, I take my calculator. I go arc sine, and I'm going to type 0.2. And I get this answer, 11.5 degrees. That's my reference angle. And here's what you tell yourself. I'm in quadrant 3, and that's a reference angle. So the one in red, theta, you're going to find that by doing what to that 11.5? Yeah, I heard someone say it. Say it loud and proud. What did I do, guys? I heard one of you say it. What did I do? Come on, guys. You have no idea how to find theta. Yeah, you had 180. 180 plus 11.5 degrees. That's all you do to get your theta by itself. Look, it's a graph in red. I already told you that the reference is 11.5. This right here, this little guy right here is 11.5 degrees, guys. So you do 180 plus that. This little guy here is also 11.5 degrees. So to get the other one, it's in quadrant 4. You subtract it from what? 360. 360 minus 11.5. And there it is. So let's see, 360, 350, 350, is it 348.5 degrees? And then the one in red, 180, 190, 191.5 degrees. Make sure to put the degree symbol. Yeah, that's it. That's all you do. Ask me questions, guys, because I can't read minds unless we're like not sure where we're at all. And then we have to go back even further. Okay. All right, let's continue. All right, question 6. It says, draw a horizontal, vertical, or diagonal. I'm going to go slow to represent the equation tan theta equals negative 0.7. And then use the line to help you solve the equation between 0 and 360. Express your answer in degrees. All right, tangent is negative in what two quadrants? Second and fourth. Perfect. Now, something to know, and I'm not a big fan of this, but I'll go ahead and tell you. Tangent, because tangent of some angle is y divided by x, and because it goes through the origin, this is kind of like slope. And I'm going to write that. Kind of like slope. Well, Chav, I don't understand. Why is it kind of like slope? Wasn't slope changing y over changing x? Yeah, well, and that's what this is. This y divided by x is like y2, whatever that y value is, minus 0 over x2 minus whatever that x value is. So what you're going to do when you get to delta, you're just going to make sure that the slope is negative 0.7. That's all you're going to do. And don't worry, I will show you an example just in case. All right, how do I figure this out? Well, I'm going to find my reference angle, theta r. I'm going to go theta r equals arctan of 0.7. Notice that I've made it positive. I take my calculator and I go second arctan of 0.7 and I push enter and I get 35 degrees. So 35 degrees. Now remember, I'm in quadrant 2. So what do I do with that 35 degrees to find my first angle? So no, not add it to 90. Subtract it from 180. So 180 minus 35 degrees. So what's that? 80, 70, 60, 50, 145, I think. All right, theta 2, that's a subscript. It doesn't say the quadrant 2. It's a subscript. It's in quadrant 4. I'm 35 degrees away from 360. Here's the 35 degrees. So how do I find that angle? 360 minus 35. Let's see, 330, 325. I want to say it's 325. Let me know if I make mistakes all the time, so let me know. Are we okay? Nothing crazy, right? Pretty basic? Nothing crazy? Okay. All right, here we go. Don't worry, we're just going to do the easy ones. So I'm actually going to cancel one of the deltas because we're not ready yet to tackle the more extreme ones. So here we go. We have something like 8 cosine theta plus square root of 20 equals 0. If you had a hard time with algebra, you're going to have a hard time here. Because we're starting to start solving equations, guys. So if you had a hard time in algebra, make it a point to start coming in, because it's the same thing, but now we're just messing with trig equations. All right. So how do you solve for theta? Well, you want to isolate cosine theta. So how do you do that? Move the square root of 20 to the other side. So it's going to turn to 8 cosine theta, and because I'm moving it to the other side of the equal sign, it's going to be negative square root of 20. Does anyone have issues with that? Yeah, just subtract. Next, I have a product, 8 times cosine theta. How do I get rid of the 8? Divide. So I'm going to have cosine theta is equal to negative square root of 20 over 8. Are we okay so far? Okay. I'm going to find my reference angle. I'm going to change my color. And I'm going to write theta r equals, and I'm going to say arc cosine or inverse cosine. Yeah, it's the same thing. Arc cosine, and notice that I'm not putting a negative inside. Chav, why? Because I'm finding my reference, not my official theta 1. Are we okay so far? Okay, is anyone freaking out? Okay, take your calculator and practice with me, guys. Practice with me. Make sure it says degree. And I'm going to go second arc cosine, and I'm going to put square root of 20. And then I get out of there, and I put divided by 8. And I push enter. And I get this answer. Did you guys get the same answer? Okay, so I put equals 56. Put a degree symbol. It says nearest tenth, so I just put 56.01, so 56. We're okay so far? Okay. Here's what you do with that 56. Child, what do I do next? Where is cosine negative? What two quadrants is cosine negative? Remember that cosine's an x value.
First and fourth.
No, and first and fourth are both positive. Yeah, 2 and 3. 2, I'll write it here. 2 and 3. So if you're in quadrant 2, so here it is, theta 1. If you're in quadrant 2, you're going to take the 180 and you're going to subtract the 56 degrees. Yay or nay? And if you're in quadrant 3, I take the 180 and instead of subtract, I'm going to what? Add the 56 degrees. Does that make sense? Now ask me questions, guys, because I can't read minds. Yes, ask. Yes, because this square root of 20 over 8, maybe it helps if we draw a visual. You're somewhere right here like that. So this reference angle right here, that is 56 degrees. So if I'm in quadrant 2 and I want to know this angle in sky blue, I got to go, you're 56 degrees away from 180, so you got to go 180 minus 56. And in the other one, in this one right here, remember the reference angle is 56 degrees. So now you're 56 degrees away from 180. So I got to add 56 to the 180 if you're in quadrant 3. That makes sense? What's 180 minus 56? What'd you guys get? 124? What'd you guys get for the other one? 236? I was about to write 1. That was silly me. Okay. Yay or nay? Okay. Go to question 8, and we're going to go slow. I'm going to go slow, guys. I'm going to go as slow as I can. I can't go any slower because then I'll put everyone to sleep. All right, here we go. On the left-hand side, I have 9 sine c minus 7 of the left-hand side of the equal sign. On the right-hand side of the equal sign, I have 3 sine c minus 1. You want to grab all the sine c's together. So subtract, I'm going to move that 3 sine c, subtract 3 sine c. So what is 9 minus 3? So I write 6 sine c, and then I'm going to move that negative 7 to the other side of the equal sign. So when I do that, you add 7. So negative 1 plus 7. 6 as well. All right, and then real quick, side note, because I don't know if I talked to this class or not. A plus, don't write this down, just listen. A plus B equals C plus D. All right, I know teachers in the past, and I'm not talking smack, I promise. So I don't want to hear anyone go to Ms. Torres and, oh, Chavez talks smack. Like, I'm not. I promise I'm not. I know teachers in the past like to do minus B whenever you move stuff to the other side. I'm not a big fan of that because I feel like it's just adding more clutter to the work. I just put arrows. If I move something to the other side of the equal sign, I just change the polarity. So if it was positive, it turns negative. If it was negative, it turns positive. If I move it, but I'm still in the same side of the equal sign, then I don't change the polarity. I leave it the same because I haven't done anything. Does that make sense? Like in chemistry, you have 2 oxygens on the left. You can rearrange it however you want. If it's still on the left-hand side, you have 2 oxygens. And then you guys have done equilibrium, like you guys balance equations, right? Okay, yeah, it's the same. It's the same as chemistry. So whenever you move something, okay, I don't have to talk to the choir. You guys know what's up. You guys are smart. Okay, here we go. I want to get sine c by itself. Divide both sides by 6. So then I have this. Sine c equals 6 divided by 6 is 1. You don't need a calculator for this one. I think you can do it without a calculator. On the unit circle, there's only one value. Between 0 and 360 on the unit circle, at what angle is sine 1? Remember, sine is a y value. Not 0 degrees, that's cosine. 90. So you can just go C equals 90. Will the calculator give you 90? Heck yeah, it will. Look, if you were to go, Chav, I want to use my calculator. Like, I paid $150 for this calculator. I want to use every button. Okay, let's use every button. Second, arc sine. Put a 1 in the inside. Close it. Push enter. And OMG, look at that. Now make sure you recognize that this is a degree. Okay, you know what? I just want to make sure that you guys know. Because I just want to make sure. Real quick. Don't write this down. Just listen. If I told you I'm in radian, what's arc sine of 1 in radian? 90 degrees. What's 90 degrees in radian? Pi over 2. Now, when you do this in the calculator, you're going to say, Charles, that's not pi over 2. Yes, it is. Check it out. So you get something like this, and you're like, that's not pi over 2. It is pi over 2. Look, second pi divided by 2. And if I push enter, there it is. It's the same digit per digit. It's pi over 2. Now, if you have something called the CAS, which I've seen some of you with the CAS calculators. If you have a CAS calculator, the CAS calculator will give you the printout of pi over 2. The TI-84 is not a CAS. Sorry. If you're wondering, like, why didn't I buy a CAS calculator? Guys, remember, you're going to be testing all your life. if you're worried about speed, unless you memorize all the shortcuts, the TI-84 you can be so fast. With the Inspires, don't get me wrong, the Inspires is an awesome calculator. It's an awesome calculator, but the drop-down menus slow you down because you have to push a lot of buttons to get it to execute to do your thing. Does that make sense? Like when you're doing a window, on a TI-84 you just push one button. On a TI Inspire, you have to push 4 buttons. You know, graph, second, edit, window, and then boom. Like, see, so don't worry, when we talk about SAT, if you guys want to come after school, we'll talk about how to use the calculator, how to be fast. Okay, here we go. Let me change this back to degree mode. All right. Next question, number 9. Okay, I'm going to go slow because the calculator, our calculator doesn't have a cotangent unless you have a CAS. The CAS does have a cotangent button, but relax, it's not going to be an advantage. Look at this. Move the 7 to the other side. 4 cotangent theta equals -7. Oh, some of you on your exam, you're not putting an argument. When I say argument, cotangent cannot be by itself. Some of you are doing this. Don't write this down because this is wrong. Some of you guys are doing that and not putting anything on cotangent. When have I ever done that, guys? I've never done that. So I don't know where are you getting that. So cotangent needs something. It's like saying f of x equals, don't write this down, just listen. It's like saying this. It's like if you wrote f equals, like you've never seen a book say f, it's f of x. So, okay, I'll stop. That's me, that's me getting rowdy for you guys not putting, okay. All right, what were they saying? Oh yeah, that right there. Okay, next, you're gonna divide by 4, right? So you're gonna write cotangent theta equals -7/4. And I know what you're thinking. You're like, oh yeah, I know how to do this. I'm just gonna find the reference angle by dividing by 7/4. And you're like, okay, I'm gonna go ahead and do that. Theta equals arc cotangent. So you put cotangent to the -1 of 7/4. And then when you're about to type this into the calculator, you realize, you come to the calculator and you realize, is there a cotangent button? There isn't. Relax. It's not the end of the world. You're not a robot. You know how to find this. Child, but how? Cotangent and tangent are reciprocals of each other. Do you guys remember that? So I'm going to put side note, change to tan. So from here, I'm just going to write this. I'm going to write tan, and it's that same angle, equals, and I just take the reciprocal, -4/7. Not opposite reciprocal, that's perpendicular, just reciprocal. You just flip it. Does that make sense? So this angle, so I'm going to come back over here now. So that angle is just arctan, or the reference angle, I should put reference. The reference angle is arctan of 7/4. So what's my reference angle? So I take my calculator and I go arctan of 7/4. Did I do that right? Or is it 4/7? Yeah, I couldn't remember. Yeah, 4/7. Man, I knew something felt wrong. 4/7. Let me do it again. Don't look at that line. Second arctan 4/7. All right, 29.74 degrees, 29.7 degrees. So I'm going to write 29.7 degrees. Okay. You guys ready? Don't worry. Yeah, don't yawn. That's a demerit. That's 2 demerits. 2 demerits for yawning. Okay. Yes, ask. Oh, I thought you had a question. Okay. Here we go. That's my reference angle. That is not the angle I'm looking for. I know that tangent or cotangent, doesn't matter, they're both the same. Well, they're reciprocals of each other, but they're both the same in the same. The sign is the same in both quadrants. I know that tangent is negative in what 2 quadrants? Second and the fourth. So this is my reference. So what you want, look, you know what? I'm going to do something just because I want to make sure that you guys know. So I'm going to store this into A. Don't worry, you don't have to do this. You know what? As a matter of fact, put your pencils down, just listen. Second and the fourth, look at this. 180 minus A, and I get this value. So this is one angle. I'm going to round it a little bit, 150.3. And then if I'm in the fourth, that means 360 minus A, right? 360 minus A. So here's my, and I know I told you not to write, so don't write this down. Now remember, what did we say it was? Negative, okay, so tangent is -4/7. So real quick, don't write anything down, just listen, watch. -4/7 is this number. And it's going to be the same digit per digit. Well, I don't know. It might be off a little bit because I didn't save it to a register. All right, so look at this, guys. If I type tan of this number Now, remember, this number goes forever, but I'm cutting it at that 7, at that 8, 7, so it might be off by 1 digit, but it's still going to be pretty good. Check it out. If I put 10 of that, look at what happens. Yeah, I knew it was going to be off by a digit because we're cutting it. But look at, it's the same number. Oh, you guys aren't impressed? It's the same thing with the tan one. Look, it's the same with the 330. It's going to be off by a digit. It's going to be off by a digit because we're rounding it. We're not using I didn't store this one into register, so I'm rounding it. Look, if I type this number in, it's going to be the same. Look at that. That is, in case you're wondering, Chop, I have no idea what I'm looking at. That's negative 4/7, guys. That's that negative 4/7 that I was talking about. Do you guys see what I'm talking about or no? Okay. All right, now you can write stuff down. So what do we say our angles are? 150 point what? 150.3 and 330.3. So theta equals 150.3 degrees and theta equals 330 point, was it 330? Short-term memory, I already forgot. Yeah, it is 330. 330.5. 330.3. Yeah. We're rounding it, not truncated. Are we okay? Don't worry, we're going to practice some more. Chav, this is so hard. Relax. We're practicing some more. Plus, we haven't had a formal discussion on this, so maybe that's why it's really tough. So we're going to have a formal discussion on the next one because those are pretty tough, the next trig equations. All right, here we go. Ready? I'm going to go slow. What do? Move the what? Move the 7. Right now it's negative, so it's going to turn into a positive. Now what do? Divide by 6. Oh, you didn't sound excited. This is exciting. Divide by 6. Yes. Hell yeah. Oh, can I not say that? I mean, I am recording, so whoever plays. I think hell yeah is okay. Give me a hell yeah. Okay. All right. I'll stop. All right. How do I get theta by itself? Well, they're already making it nice for me. That's already a positive number, 7, 6. So theta equals, what did I write? Arctan. You can also say inverse tan of 7, 6. This is going to give you an answer. All right, guys, focus. This is going to give you an answer in quadrant 1. Where else is tan positive? Quadrant 3. So this is going to give you a reference angle between 0 and 90. All you got to do is whatever reference angle you get, add it to 180. So here we go. Arctan, second arctan of 7 over 6. Push enter. So there it is, 49.4 degrees. 49.4 degrees. So how do I get the second answer? Add it to 180. So 180 plus 49.4 degrees. So what do you get? Let me just push plus 180. Plus 180. 229.4. There it is. How do we feel, guys? Okay. Can we take some more? Okay. Don't worry, these are simpler. All right. I'm going to go slow. Because some of these questions I put in here on purpose because I saw that we need a lot of work, some of you. And I mean that with love. I don't mean that with anything but love. All right. If everyone was perfect, then I wouldn't be needed, right? So it's probably a good thing that because you guys are keeping me with a job. So you know what? Be mad at math. No, that was a joke. All right, here we go, guys. Here it goes. Focus. All right, guys. If sine theta equals -½ so already there is a perfect coordinate. You should already be thinking like, oh, okay. And look, they're being nice to us. They don't have to give us this, but they did. And the reference angle is 30 degrees. They didn't have to give us that. They did. They're being nice. Find both angles in degrees and radians. Okay, so I'm going to put the degrees in the left, and I'm going to put the radians on the right. All right, in degrees, my reference angle is 30 degrees. Sine is -½ What quadrant is sine negative? In quadrant what and quadrant what? 3 and 4. My reference angle is 30. They didn't have to tell us that. They're being nice. So that means add 30 to 180. Theta is 210, but you already knew that. Sine of 210 degrees is -½ And in quadrant 4, you're 30 degrees away from 360. So that's going to be 330. But you already knew that sine of 330 was negative half. And I should say sine of 330 degrees. Cool or not cool? All right, now I need my radians. What is 210 degrees in radians? 7 pi over 6. The denominator is 6. The integer is 1 more than 6, so 7. And in quadrant 4, 11 pi over 6. Keep the denominator, double it, and subtract pi over 6, or subtract 1. Are we getting better at this? All right. Question 12. Don't freak out. That is a perfect coordinate. You just don't recognize it. Because you just need more experience, that's all. That's how it is with everything, guys. In life, you just need to be exposed to something to be really good at it. LeBron James didn't just wake up and say, oh, let me play basketball now. Like, you know, he practiced. Now, he did have skills. Yeah, you're right. If I were to play basketball every single day, will I make the NBA? Probably not. But will I get better at basketball? I will. I'll beat everyone in here. I'll beat everyone in this room. I don't know if I can beat Montalongo, but all right, here we go. Don't show Montalongo this one. You know, maybe I won't put this one up. All right, here we go, guys. Focus. The reciprocal of cosecant, in case you don't recognize it. So here we go. I'm gonna write sine theta equals, and I'm just gonna take the reciprocal, 3 over 2 square root of 3. And I know what you're thinking. Chav, that question, this 3 over 2 square root of 3, that's not on the unit circle. That's not a perfect coordinate. You lie. Well, I didn't lie. I don't know why I said it that way, guys. If I multiply this by square root of 3 over square root of 3, look what happens. You get 3 square root of 3 over, and then 2 times 3 is, and then this reduces. Like, Chav, you still lie. Like, look, that's not, no. Look, reduce it. How many times does 3 go into 6? 2. Square root of 3 over 2. Look at that. That is a perfect coordinate. And look, they're nice. They don't have to be this nice. Look, the reference angle is 60. They're being so nice. Look at that. Sine is positive in what 2 quadrants? 1 and 2. Yeah, 4 is the cosine. 4 is the cosine. 1 and 2. So here we go. Theta equals, if you're in quadrant 1, 60 degrees. If you're in quadrant 2, what's 180 minus 60? 120. But you already knew that. You already knew that sine of 120 was square root of 3 over 2. That's in degrees. They also want it in radians. Theta equals what 60 degrees in radians? No, not pi over 6. Pi over 3. It's all good. It's all good. What about in quadrant 2? 2 pi over 3. Look at that. Did you guys ever think that you'd be this beast when you guys were... Did you think that one time... Look at all the work we've done. Look, zoom out. Look, I'm zooming out. Did you ever think that you were going to be able to do all this? But now you're doing it. All right. All right, here we go. Here we go, guys. Focus. We're almost done. Don't worry. We'll give you guys some time to work on your delta in a little bit. Question 13. Look what question 13 says, guys. Focus. It says, draw a horizontal, vertical, or diagonal line to represent the equation sine theta equals negative half. Now they're forcing me to draw one of those. And then use the line to help you solve the equation. Okay, to solve it in radians. Okay. Sine, is it the x value or the y value? Y. So this is like saying y equals negative half. It's like saying that. Here's negative half, point, put a line connecting those two dots. There it is. That's your y equals negative half. Do you guys see that? The angle they want, you already know the angle. I mean, I hope you do, because we're going to take another unit circle quiz next time we meet again. This is the angle they want. I'm not throwing shade, I promise. That's the angle they want. They also want this angle in sky blue. I call it sky blue. I don't know if it really is sky blue, but it looks like, if you look up at the sky, it looks like that blue, right? Okay, that's why I call it sky blue. All right, here we go. You can use a calculator if you want, but you don't need a calculator. Theta equals, at what angle is the y value negative half for sine? At what angle is the y value negative half for sine? 210 degrees. And what's the other one? 330. Now actually they didn't even want it in degrees. They just wanted it in radians. No. All right. Oh, they said both? Okay. What happened? Yes, there is on that one. Yeah. That's the only one. All right. Here we go. In radians, here it is. What is 210 degrees in radians? Try not to look up there because it's the same, I think. What is it? Yeah, 7 pi over 6. What about a 330? Ah, don't look up. 11 pi over 6. Sorry, I'm laughing at myself because I covered my laptop like if it was going to cover that. So it's been a long day. Yeah, well, who's been awake the longest in here? Did anyone wake up at 4 in the morning? Yeah, I usually don't ever do this, but I overshared today. I'm not a big fan of oversharing. Today on my Instagram at right around 5 in the morning, I'm like, I want to let the whole world know that I'm at Whataburger doing grading papers. So I took a picture of I was at Whataburger. I took a picture of the homework, but I made sure that you could see the background, that you could tell I was at Whataburger. And look, I'll even show you because yeah. See, so I put that, and you can tell the background, and I wrote one of my many flaws. I have a habit of waking up in the middle of the night, going to Whataburger and grading papers there. Been here since 5-ish. Woke up at 4 a.m. and figured might as well start my day. And I wrote more stuff, but whatever. I know. It was just a sausage bob, and all right. I feel like one of these days, and I'm kind of joking but kind of serious, but I don't want to die, but I have such bad sleeping habits, like so bad. Like I fell asleep last night, like probably close to midnight. I probably only slept like 3 hours, 3.5. And then I got up, I went to the restroom, and I'm like, well, I'm awake now, might as well. And I just decided to just get dressed and go out. Like, so I should have just gone back to sleep, but one of these days I'm just gonna fall, and just I'm dead. All right, guys. Last one, and then we'll set you guys loose because I think the rest. All right, guys. Let's do one more, and then I think that's it, and then we'll set you guys loose because I think the rest will have to wait for another time. So here we go. Draw a horizontal, vertical, or diagonal line representing cosecant theta of -2. Relax. Yeah, perfect. So you should always turn this into sine. You should always do the reciprocal, and then just call it -half like that. And then look, it looks exactly like the last problem we did. So just like 13. Just like number 13. It's the same answer. It's the same answer as number 13. Does that make sense? Okay. You now have the skills to tackle one of your delta math. You're not going to be able to do the second one, so don't even attempt to look at it. As a matter of fact, I'm going to delete it as soon as I get online because we're not ready. Not delete it, just hide it from you guys. So at the moment, both delta maths are showing. Don't even attempt the second one. You're just going to attempt which one? Just the first one, the one that says A or part 1. So that's it, guys. Now let's get some practice, and we're good.